Hello, linear algebra student. This video is for chapter 1.1, part 3. We are looking at something called consistent and inconsistent systems. In the last video, we talked about how to solve if a system has solution using elementary row operation. It turns out that elementary row operation can also help us to detect if the system is consistent or inconsistent. We know if it's you can actually do that if it is a 2 by 2 system and we graph it. If it is a like a parallel line that doesn't meet with each other, we know that it's inconsistent, right? And if it is two lines that meet with each other, then you have one solution is a consistent system. Or if it is same line, it's dependent, the two lines are actually overlapped, then it's also consistent. It's just an infinite in many system. But if you have like 3 by 3 or n by n system, how can you detect it is consistent? It turns out the elementary operation can do that. So look at this. These are augmented matrix from a system, so we can actually record it back to see if they are consistent or not. So this is x1, remember this is x2, and this is the B column. So that means x1 plus x2, 2x2 is equal to 4. But then there is no x1, no x2, 0 equal to 2. This is contradiction, right? Untrue. This statement is not true. So this system can never have any solution because no matter what x1 and x2 is, you can never satisfy 0 equal to 2. So this is a no solution system and it is inconsistent. So the idea is if you have a equation in the system that is a contradiction, then you have no solution. So the idea would be to look at, if you have an augmented matrix, once you have a upper triangular, so for a 2 by 2 system, this is 0 is already upper triangular, and you convert it back, you look at if you have a contradiction, that would be it. So look at this one. It will be x1 plus no x2, 2x3 equal to 5. It's not contradiction. It depends on what x1 and x3 is. And then we have 2x2 minus 3x3 equal to negative 7. This is also a regular equation. The last one is x3 equal to 0. It is also actually a regular equation. It is true only if x3 is true. So all of these are okay. So this means it is consistent. You can have the solution being 0, and this is okay. But you should not have 0, a number equal to 2. So you really don't want to have any 0 on this side, unless it is all 0. So if you have, just think about if it is 0, 0, 0, then that's fine. It's not a contradiction. So you cannot say that, okay, so anytime you have this non-zero shows, a non-zero shows up here, then it's a trouble because if you have 0, 0, 0 is fine. So last one, is it consistent or inconsistent? So it is an upper triangular, right? This is 0 and this is also 0. The third one, this is also 0. So let's look at x1 plus no x2, x3, 2x3 equal to 5, then x2 equal to negative 7, and then you have 0, so there's no x1, x2, x3 equal to 8, and this is a contradiction, right? So this one is inconsistent, no solution. Inconsistent. Again, if this is a 0, if I have 0, 0, 0, 0, 0 equal to 0 is okay, and then it is a consistent. So what about if I start off with actually the system and I have to do some row operation to figure out. So 0, 1, 3, 1, 1, 0, 1, 0, 1, 1, 4, 2. So this is the augmented matrix. I'm going to do the upper triangular. First of all, well, this is not I don't start off with a 1 in the upper left corner. So I switch 1 and 2, maybe. Switch 1 and 2. So I have 1, 0, 1, 0. The first 0, 1, 3, 1. And then 1, 1, 4, 2. The third one. So it has this benefit of having the 1 in the left corner. And this is already 0. So I just need to get rid of the 1 here. So by multiplying R1 by negative and plus R3 and put it back into R3. So I would have negative 1, 0, negative 1, 0, add to 1, 1, 4, 2. I will have R1 still 1, 0, 1, 0, R2 still 0, 1, 3, 1, and then R3 become what? Add this together is 0, 1, 3, 2. Okay. Now I'm going to get rid of this one, right? So you cannot just, figure it out. You have to get your augmented matrix in upper triangular in order to see if it's consistent or not. Otherwise, it's hard to tell. So I'm going to get rid of this by saying what is the things that I need to do. R negative R2 plus R3, right? Put it back into R3. So that means 0, negative 1, negative 3, negative 1 plus 0, 1, 3, 2. And you can see I have 0, 0, 1. 1, 0, 1, 0, 0, 1, 3, 1, 0, 1. Oh no, 0, 0, 0, 1. So this is upper triangular, but if I write it back, I would have x1 plus x3 equal to 0. X2 plus 3x3 equal to 1, which is fine. This is not a contradiction, but the last one, 0 equal to 1, is contradiction. Contradiction. So no solution or inconsistent. So you don't have to continue to solve now. There are other questions like the following question. Find H so that this system is consistent. Okay, so to be consistent, that means you don't want to have any 0 equal to a non-constant, right? So let's look at how we can do it. So convert it into upper triangular. So this is a negative 2. I want this to be 0. So I would do 2R1 plus R2, put it back into R2, right? So that would be 2h, negative 6, right? Negative 2, 4, 6. And we put it back into R2. So 1h, negative 3. This would be 0. 2h plus 4. And then 0. So for it to be consistent, what can we do? We can have 2h plus 4 equal to 0. That would be a, so this would be, so this is x1 plus h of x2 equal to negative 3. This is not contradiction. This is 2x plus 4 equal to 0. Okay, so when is 2x plus 4 equal to 0? When is it not contradiction is if you can actually solve it, right? So how can you solve it? So if h is 2h plus 4 is actually 0, then that's consistent, right? If 2x plus 4 is not equal to 0, so it has to be equal to 0. But if it's not equal to 0, I would have like 5 or something equal to 0. That would be contradiction. So that would be no contradiction, right? So you really want 2x plus 4 equal to 0. That means 2x is equal to negative 4 or x is equal to negative 2. So at x equal to negative 2, that would be consistent. Only if that is the case. Just think about if x is equal to 1, so you would have 2 plus 4 is 6. So 6h. Um, hmm. I think maybe actually if when it would it be because this is actually x2. So if it is equal to that's consistent. If it is not, then what happens? So if this is like 5, 0, that just means x is equal to 0, right? So I think x can be anything actually, right? So if 2x plus 4 is not equal to 0, I think in all cases this is okay because the fact is that this side is 0. Guarantee that you are okay. Then you will have x2, 2x plus 4 equal to 0, then just x2 would equal to 0. So I think h is not equal to -2 is also consistent. But now if this is in other question, if this after you do the elementary row operation, this is kind of a tricky question. This is a 1, then you would not want 2x plus 4 you want it to be you want this to be equal to not 0. Okay, so in the case of 0 here, I think 2x plus 4 can be any number. So that means h can be any number. If it's 0, it is when it is -2, 0 is 0, it is consistent, it is not a contradiction. If it is not 0, so then x3 will just be 0, right? So it's still okay. You can still solve it. Okay, so that is all for chapter 1.1. For the main thing you need to learn is how to use elementary row operation to detect a system, and also how to use elementary row operation to detect if a system is consistent or inconsistent.